Alright, now let's look at some transformations with these graphs, and we're actually going to start out with y equals 3 raised to the x power. Now, it might not be quite as obvious as we're looking at this one right off the bat here with y equals 3 to the x, and again it shows up a little bit different on the on-screen calculator here, but remember this is showing me y equals 3 raised to the x power. Alright, so let's take a look at what happens with some of our shifts. We're going to look at x plus 1 all being in the exponent. So that'll be our second one here. So we'll have y equals 3 raised to the x plus 1. And you can write it with the parentheses or without the parentheses. And then we're also going to look at, and this one looks pretty close to what we've got up here, but we're going to change it around here so you can see how you'll look in the book. 3 raised to the x, and then not in the exponent, minus 2. Now, a couple things to remember when we did our changes before. When we were dealing with our x's, we always were thinking opposite when it came to graphing. So we're going to see if the same thing happens here. In the past, this would have meant we would take anything, shift it to the left 1 unit. And if that happened, we kept the same size, the same shape, it just went left 1. When we get down here, this x is the only thing in the exponent, so this is going to have an effect on the y, which means we don't do opposite, you do just what you see. So this says minus 2 for y, so every one of these y values should end up shifting down 2. So let's take a look at what happens on the picture here. So our original one, y equals 3 to the x, we've already got graphed here. Now we're going to add in the 3 to the x plus 1. So let's see what happens when we graph it. Alright, there we go. So there's our graph. So when we look at this one, this is y equals 3, and the entire exponent is x plus 1. So we were saying that this said every x should go to the left 1. So remember our magical block right there at 0, 1. If I go 1 to the left with that one, now instead of 0, 1, I should be at negative 1, 1. So that one just went 1 to the left, and actually the entire graph just shifted 1 to the left. So all the points shifted, size stayed the same, shape stayed the same, orientation stayed the same. So what we've done in the past, when we've dealt with the x's, we always thought opposite. So plus 1, normally we think positives to right, we just went 1 to the left, and there's our new graph. Alright, let's take a look at that second one. So let's regraph this and take a look at what happened. Alright, on this one, the first graph we had again was our top one up here, y equals 3 to the x. Our new one right here was y equals 3 to the x, like we started with, and then we did a subtract 2. Now again, because this minus 2 is not hooked to the x, this is going to be a vertical shift, and we do exactly what it says, in this case, down 2. So again, that lock point at 0, 1, if I take 2 away from positive 1, I get negative 1, and there it is. So this went down 2, the point that was here went down 2, the point that was here went down 2, everything went down 2. Now the other thing that we should remember is we had that asymptote at the x-axis. That same asymptote also has to go down as well. So right now, one thing that we should probably add to this graph would be to put in our asymptote. So let's take a look at what that would look like. So we would go down here to where y equals 2, and we would just put our asymptote in right along that spot. So the asymptote moves when we have a vertical shift. So now we add that in. So again, everything ended up moving in that case. Alright, let's take a look at two other options here. And let's see what happens when we start changing some signs and some values here. So let's go back to our original graph, our y equals 3 raised to the x, and this time let's make this change. Alright, so we're going to make the change, we're just going to negate the value out front. So let's see what we think might happen with this one. Alright, when we looked at this in the past, we said, okay, look at that negative. It usually means a reflection. So we're going to see if this does the same thing. So negative usually tells us that we're going to do a reflection. And in this case, since it's on the outside, it affects the y. So every y value gets multiplied by a -1. So the y should flip. So it looks like we're going to get a reflection over the x-axis. Well, let's take a look and see if it actually does that. So we're going to open this graph up, and we'll graph it. So we're looking for the green one. There it is. So the point that we did have originally, that lock point at 0, 1, flips to 0, -1. So every value that we had up here, we had an x value and a y value. Now its mirror is down at the same spot for x, but the y has been reflected. Kind of what we thought would happen, and it's the same thing that happened with our transformations in the past. Alright, let's take another look here. Let's shut that one down for a second, and let's open our next one up, but this time let's go with the exponent becoming a negative value. We'll get rid of this 2 so we don't confuse people a little bit more. So again, we're going to go with our original y equals 3 raised to the x power. Now since this one is hooked to the x, we would expect it to reflect over the y-axis. So let's take a peek at that. So we're looking for the blue one this time, and that's exactly what happened. So everything we've done in the past happens again. Still got that lock point at 0, 0, but again, this time, whatever value we had out here at x, y, this time it reflected over this side. Still stayed at the same y value, but this time the x ended up being the part that got reflected. So everything that we worked with in the past, as far as our transformations, it's going to stay the same when we go through each of these as well. So